So hi there everybody, welcome to my channel. So today in this video we'll be discussing on sparse matrix multiplication, and also in this video we'll be covering on the data structure of the sparse matrix, and we'll also learn how can we represent this sparse matrix using the arrays and linked list, and we'll also try to learn the advantages of the sparse matrix, and also we'll try to learn the real world application of the sparse matrix. So guys, let's get started. So yes, now let's begin our topic, that is a sparse matrix multiplication. So you might be having a question, what is a sparse matrix? So the sparse matrix is basically just like an ordinary matrix, but in this matrix it contains most number of the elements as a zero elements. So in the other matrix where we usually see that most of the elements will be like, it can be like variety of numbers, but in this sparse matrix especially we'll be seeing more number of zero element other than the normal elements. So other than this, you might be having a question like, why is it used? So we use sparse matrix because it provides a better storage efficiency, and it provides a better computational efficiency, and it can be well optimized in the tech world, and even it provides a better memory and bandwidth saving, so that it allows us to transfer huge data across the globe at a faster speeds. So when it comes to data structures for the sparse matrix, so basically we see that there are linked list, arrays and hash tables. So this linked list, each non-zero element is represented by a node in a linked list, and in arrays, non-zero elements are stored in an array along with their row and column indices. And then we have the hash tables. So at the non-zero elements are stored in a hash tables using their row and column indices as keys. And especially in this video, we'll be mostly covering on the linked list and arrays, because these two are the most important things. Now let's come to the array representation. So in this array representation, what we do is we access the elements more often, and since the array store the elements based on the indices, so this will be much helpful. And in this array representation, we convert this two-dimensional array into one-dimensional array by using three columns, and we'll be representing these values in the forms of rows, column and value. So now let's take a look on this, how we represent the elements in the array representation format or array representation. So this will be our matrix, and this is a tabular view in which you can see we have rows, we have the columns, and we got the values. So this thing will be the row part, and this part will be the values, the columns. So the indexing will start as 0, 1, 2, and this will be the 3, and this will be 4. And similarly on this side it will be 0, 1, 2 and 3. So as you can see, we need to find the non-zero element. So the 3 is our first non-zero element. As you can see, 3 is present in the 0th row and the second column. So since we got our values as 0 and 2, and similarly if you go and try for the value number 5, so our 5 is here and it's present in the row number 1. As you can see, this is in the row number 1, our 5 is in the row number 1, and it's in the column number 2. So as you can see, it's in the column number 2. So similarly we got our row and we got our column. So and hence our element 5 is stored in the first row and the second column. And similarly you can try finding the values for these other elements. Now let's head over to the linked list representation. So in a linked list where the frequency of insertion and deletion operation in the matrix is more, so it is easier to delete and insert the elements in a linked list as compared to the arrays. So in this linked list representation, it consists of rows, values and columns, so which was similar to the array representation, but we have an extra thing here, that is a next node or the node thing. So what this node does is it connects the one list to another list. So we basically connect the end of one list to another list. So now let's take a look at the linked list representation. So we got our same matrix here, which is similar to the array representation, and then we got our linked list here. So before going to the representation, we need to take a look at this node structure. So this first box in the linked list will be representing the row, and the second box will be representing the column, and the third will be representing value, and the fourth will be representing the address of the next node. This fourth box will be carrying the address of the next node to which your list will be connected. So that is why this fourth box comes to use. So now similarly we got our rows here and this is our column. So similarly to the previous array representation, so now let's take a look at this first example. So we got 0, 2 and 3, and 3 is our value. So this 3 will be our value, so which is a non-zero element. And now in order to index it, we got the 3 which is placed in the 0th row and it is placed in the second column. This is 0, this is 1 and this is 2. So this will be the second column. So we got a 0 in the 3 in the 0th row and in the second column. So that is why we got the 0 here, 2 here and 3 here. And similarly if you want to find for the number 7 which is here, so you can also find out very easily. So the 7 which is placed in the first row and it is placed in the third column. So that is what you got the values as here, that is 1 and 3. Now similarly you can try finding out to the other elements. So let's take a look at the advantages. So this sparse matrix representation comes with a lot of advantages. So it mainly includes like reduced storage requirements, it can be computational efficiency, it can be optimized performance, it can be memory access efficiency, and some other more popular problem specific applications. And next thing is application. So if you take a look on the application, the sparse matrix comes with a lot of application. It's used in a lot of fields. It can be like scientific computing, it can be using like machine learning, natural language processing, or even a sparse signal processing. So these are the applications in which we can use this sparse matrix representation. So to conclude this video, we can say that sparse matrix multiplication offers efficient computation, reduced storage needs, and targeted solution across diverse fields like science, engineering, and data analytics. So that's it guys. Thank you for watching. Bye.